Okay, now we are going to continue our exploration of regular expressions by exploring how we can use groups within regular expressions and also how we can use regular expressions to modify texts. But before we go on, I just want to put in a reference to my favorite resource for regular expressions, and that's the regular expression how-to document, which is available on the Python website, and this links to it. So a regular expression might consist of a variety of pieces. When we think of like a name, we have a first name, a middle name, and a last name. We can, in addition to matching the whole expression of a name, we can access through regular expressions the particular parts of the regular expression. And we define parts of a regular expression or a group using parentheses. And when this really becomes powerful is that we can make a group optional, like a middle name, for example, is a frequently, not everyone has a middle name, not everyone might be reporting a middle name. And so that's where we can match something that may have or may not have a regular expression by making an optional group. So let's just kind of show some examples of what we mean by groups, and then we'll get into more details of it. So here I've created a kind of just a silly test string, and I'm going to make a regular expression where I'm going to match a Python or Perl. And here I've got a group that it consists of the fragment Ithon or the fragment Earl, and then we're going to look for the matches to this within the test string. So we do see, just repeating the string, that we are matching these Ithons, 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 and Earls. You notice that we haven't captured the P in this expression. We can fix that by putting the whole expression that we're going to match within parentheses, and then we have this subgroups within a parentheses. So if we repeat that here, you now see that we have the whole match, the whole group, Python, and we also have the subgroup, Ithon, showing that that's what was matched. And we have here with Perl and the substring of Earl that was matched. Okay, here's another one where I have a expression for finding Brian or Brad. And so both names have a BR, and then another group. So this would be kind of like my first half of the word, and then the second half is a group that is either ion or add. And you see that when we do the find all, we're getting a list of tuples, and the tuple has the overall group match, and then the pieces, the subgroups, the BR, the ion, or the AD. Well, like I said, parts of these can be made optional, and that's done by defining a group. Here I'm looking at web addresses, so I'm going to say, well, perhaps they specify the HTTP. So that group is optional. It doesn't have to exist for this regular expression to match. And that's because I have this question mark following the group. Similarly, here I have a www with a escape period. So that's a true period, not any character. And again, this group is optional because I have a question mark. Python is a group that has to be matched, and then I have an optional .org afterwards. So let's see what the results of this look like. Again, we have a list of tuples, and you see for different expressions that for this first match of Python, there was no HTTP or www or .org. Let's just kind of make this clearer by putting in here, and we'll print test string just so we have that in front of us as a reference. So our first occurrence of Python is just right here. Our next one, you see here we have no HTTP or www, but we have the python.org, which corresponds to this instance right here. The next one we have an HTTP, but no www, so that one we have a blank string. The next one we have a www, but we don't have an HTTP, so that's an empty string here that didn't match, and so on. So far, when we've been using the find all method of a regular expression object, and find all is useful. It returns the strings and the parts we've matched, but there is a more powerful way of working with what we've matched, and that is through regular expression match objects. And we get those by using the find iterator method of a regular expression object. And so the match object contains methods that describe the attribute of the match string in more detail. For example, it'll tell us the span of the match string. That is, what the character span is in the string where the particular regular expression matched. So let's look into that with another example here. So I'm using the same regular expression that I created above, R1. Instead of using find all, I'm using this find iterator, find iter, and I'm creating a iterator object called r iter. Don't quite know how to properly pronounce that. So it's an iterator. I can loop over the elements of that, and what I'm going to do is I'm going to print the group, the overall group that was matched, and I'm going to ask it what the span is, and that's the character locations of the match within the string. I can return either the span as a tuple, beginning and end, or I can return the start of the span or the end of the span. And then I'm going to print off the individual groups. Now for the regular expression that we're using, there are 4 groups. 1, 2, 3, 4. And so I'm going to be looping over each of those 4 groups, and I can access them through indexing through this group method. Let's see what we get here. We got nothing. That seems, oh, there we go. So I matched Python. It tells me that's from characters 152 to 158. The first group I match is Python, and then I have a none and a none Python. Then I match a python.org, and I can see here that so 0 is the whole match, and I need to redo this here. The groups are going from 1 to n, so let me redo this here. So the overall match regular expression is Python. I don't have the HTTP or the www or the .org. In this case, I got python.org as my entire match. Again, no HTTP or www, but I do have Python, and then I have the suffix .org. Here, and this again providing the span, the start, and the stop. Overall match phrase is http://python.org. So I do have the HTTP. I don't have the www, and so on. And here's one where I have all the pieces matched. Okay, so this is useful, but it does require us to know the index order of a particular object group that I'm trying to access, and maybe a more user-friendly way for that is for us to provide names for the groups that we're going to be working with. And so groups can be named in using the following convention. So I have my group started with the parenthesis. I start with a question mark, with a P, then a less than, the name of the group that I'm going to use, and then a greater than symbol, and then the regular expression definition of the group, in this case, one or more digit. So here we have a regular expression, same thing that we did before. Just kind of printing that out of how we're accessing the different components of it. And again, I'm missing the last element, but we'll move on from that. And here we are using names instead of just implied ordered groups. So here I'm using a name, regular expression to match names. So I have a group, my first group here, and I have named it. You see the question mark P. It's going to be F name for first name. And here then is my definition of the regular expression, a capital letter followed by one or more lowercase letters. Then I have a white space, which is not within the group. And then I have a middle name, which is optional, and because the middle name is optional, the space following the middle name should be part of the middle name. And you see I keep the names. So this is actually a more complex compound group. So I have a group that includes the space. Then within that group I have another group which is named, and this is middle name. This is important because if I don't have a middle name, I'm not going to have an extra space here. So that's why I have to do it in two parts. Let me see if I can make this a little bit bigger for us to look at. And then I have another group, and here I have the last name. And I actually then have the whole expression wrapped in another kind of larger container group. So we're going to apply this, compile this regular expression, and then we're going to use the find iterator to get individual matched objects and then look at the group and the span and print out what we matched. So, okay, I've got a Python error. And invalid expression, bad character range. So let me scroll up here and see if I can see what the problem is. Invalid expression. Okay, so I can't figure out what's going on here. So I'm going to go over to a shell. Okay, I think I messed up my name expression with kind of a copy and paste. So we should have A to Z with an optional period. Let's see. Okay, so what happened is I dragged over my white space. I think that was just a drag and drop error within the notebook. So let me rerun this. There we go. So my first match is Brian Chapman. This is the span. When I print out the individual groups, There's no middle name specified there, so I'm getting a none. You can see here I've matched the middle initial. Here I've matched the names and other things that look like names that aren't Brad and Bob next to each other. Obviously no middle name there. If we had a Brad, Bob, and Bill, I guess Bob would have looked like a middle name. And here we have Pearl and Pearl with no no middle name there. So if I compiled it, let's see, I didn't compile. Okay, so here you can see that kind of trying to account for more complex like Scottish and Irish names, I'm letting uppercase or lowercase follow my uppercase letter. And so that's why we're able to match Pearl in all capital letters here as looking like part of the name. Okay, so modifying strings with regular expressions. It works similarly, but what we're going to use is we're going to use the regular expression object method or substitution. And so basically what we do is we define a regular expression, and in this case I'm just defining a regular expression that matches one or more white space character. That's the /s plus. And the way that the substitute method is called is I provide what I'm going to replace the matches with, and then I provide the string which I'm going to do the modifications to. So in this case I've created a string with just some kind of messy white space use. I've got some multiple spaces, I've got some tabs and new lines worked in, and I'm going to match all the one or more white spaces, and I'm going to replace with the sub command any of those matches with a single space. And so just I'm going to print the original string and then the cleaned string. So here you can see I've got all these spaces. I got a new line break, but in the cleaned string, cleaned string, those have all been replaced, so we have a nice spaced output. And so obviously this substitution can be used for a variety of purposes, and one of the things that we'll do in class is to do a de-identification of text by identifying proper names and replacing them with randomly generated proper names. So look forward to seeing you in class tomorrow and continuing our exploration of regular expressions.